Greetings everyone, my name is Hannah Weinberger. Today I will be discussing slowed obligate cedar recovery post-fire in Dozer lines, including lessons learned from my master's thesis work conducted in Dr. Kozinski's lab at Chico State, as well as an independent project Claire Monahan conducted in Kristen's lab. Dozer lines or fire lines are a fire suppression technique where all vegetation is removed down to bare mineral soil. This is with the intention of changing fire behavior as well as allowing for safe firefighter access. Issues that can arise include erosion issues as well as a raised fire risk due to non-native invasion. Dozer lines, which we are discussing today, are a type of fire line installed by a bulldozer. The two main growth strategies for post-fire regeneration in a Mediterranean climate include that of obligate cedars, which post-fire adult individuals will usually die. They generally require fire for seed germination, and they do not resprout after fire. Secondly, there are resprouters, which post-fire adult individuals usually survive and generally will resprout from the root burl. Resprouters can also resprout in response to mechanical treatments, including a bulldozer clearing vegetation for a dozer line. The dozer line we studied was half a kilometer in length and 6 to 12.2 meters in width. On this graph, we have regeneration strategy on the y-axis and average percent cover on the x-axis. This data is broken up by treatment type in 3 panels. So we have burn on the left-hand side, dozer line in the middle, and unburned in this right-hand panel. Diving into this data specifically, this is a graph of average shrub and tree cover 2 growing seasons post-fire. We can see that resprouters had cover in all 3 treatment types, whereas obligate cedars only had cover in unburned and burn plots, although burn cover was low, but was not found in the dozer line plots. This second graph is showing woody seedling growth in the same plots sampled for average shrub and tree cover. This graph is set up the same, except it has number of seedlings on the x-axis. We can see a similar pattern with resprouter seedlings in all 3 treatment types, but obligate cedar seedlings only being found in the burned and unburned areas, and again are missing from the dozer line area. Therefore, no obligate cedars were found in any of the dozer line plots in either of our studies. So, although we studied a smaller dozer line, we can apply lessons learned here to the larger landscape and fire events. The Thomas Fire was approximately 114,000 hectares and resulted in the installation of 450 kilometers of dozer lines and roads. The Carr Fire, which was approximately 93,000 hectares, resulted in the installation of 491 kilometers of dozer line and contingency lines. Thinking about the obligate cedar loss that occurred on the half a kilometer dozer line that was sampled in our studies, we must consider what that might mean on a landscape scale for obligate cedar species, considering these larger fires have dozer lines amounting to almost 1,000 times the length of the dozer line we studied. So what can we do better going forward? One of importance is mapping and reusing fire lines whenever possible. We can also be intentional with our fuel treatments. Fire breaks and fuel breaks are types of fuel treatments that are permanent linear features on the landscape that can resemble dozer lines. So we can apply lessons learned in this talk to these other situations as well. I would like to thank all of these people and organizations for all their assistance, especially Claire and Kristen for contributing to this talk. And I would like to thank all of you for your attention. Please direct any questions you may have to the contact email provided on this slide, and I hope you enjoy the rest of the conference. Thank you so much for your attention.